Hi, welcome. I am Kamaksha Masnoru. I created a small web application for structural equation modeling, which is available from github.com/Kamakshaya. The name of the package is RGfSEM. In my previous video, I explained very little introduction to the web application. I also explained as how to download and install open in the computer, run the code, open the web application in the either in the RStudio browser or default web browser of the operating system. I am using Ubuntu 18.04. It doesn't matter. This application can be used almost all operating systems wherever it is possible to install R and RStudio. Most importantly, RStudio, because we are going to open. Once you download and open the file in the RStudio, your RStudio looks like this. Your RStudio, the file looks like this. You just have to once you open the script file, the R code, you will find this little button, run app. You just have to run this to open the app, and once you open the app immediately you will find the very first tab called data sets. I gave very quick introduction to all these tab panels, which you can see from the navigation bar. The first tab panel is datasets, which is useful to upload the datasets, which in turn used to perform the structural equation modeling. Because both for EFA and SEM and CFSM, we need to have the data available for analysis. Now you just have to press on the browse button and go to the location where you have. I am just going to upload dummy fictitious simulated dataset just for the needs of testing this application. If you observe, I have 9 data variables: x1, x2, x3, x4, y1, y2, y3, g1, g2, z3, something like that. And if I'm not wrong, or if I'm correct, the length, which means the number of rows, are 20. And with 9 variables. Okay, this is and you just don't care about this download and rest of the options available from the datasets, and this is not very much relevant for this structural equation modeling. This analysis known as structural equation modeling. These things I created for some other application, which is there in the same GitHub account, and you can just go there, and it's called RGfSEM, something like that. And now once you upload the data set is available for your analysis. Straight away go to the, in case if you would like to do some statistical analysis, you can just perform. This is summary. This tab provides summary statistics for, since this is ordinal data, much of the statistical techniques are not very much meaningful for this analysis. However, there is one simple thing called covariance, because structural equation modeling is covariance, belongs to area of theory called covariance matrices, or covariance matrix manipulation, or something like that. We're just going to manipulate the covariance matrices obtained from the data set in order to perform the structural equation modeling. You just have to read more and more about, very little about the structural equation modeling and how the covariance is, because in structural equation modeling there will be an objective function. It is all about numerical optimization, optimizing the objective function, and that objective function is we are going to use this covariance matrix of the dataset, which we obtain from the dataset, to optimize the objective function. I'm not going to talk about much of the theory, and I'm just going to show how to implement this web application, or how to use this web application to perform the structural equation model. Okay, for covariances you choose all of the variables and then go for the You see here, you will find the few of the values appears to be negative, not few. I think almost all half of the values in this covariance matrix appears to be negative. Please see that your covariance matrix do not have too many negative values, otherwise you will end up with a couple of errors while performing the structure. Not only here, in almost all, because while performing structural equation modeling, the covariance matrix need to be singular. It should not be non-singular. If you have too many negative relationships or more than very strong or very weak covariances among the variables, it may not be possible for you to perform. And another thing is correlation. Right now multivariate correlation is not available through this web application. However, it is possible to do the bivariate correlation, variable by variable. Suppose if you want to see what is the correlation between x1 and x2, then you can just use the correlation. Here you can see the Pearson correlation coefficient, also known as small r. The value is 0.75, which is positive and also strong. This is actually the statistical correlation significance test. The method used is the Pearson's product movement correlation, and there is a t-test for this Pearson correlation coefficient. There are degrees of freedom and p-value. If you observe the p-value which is less than 0.05, so at 5% significance level, it is possible for us to state that the relationship between, the relation between these two manifest variables appears to be statistically significant, which means this relationship is important for our analysis, something like that. So you can just go ahead, you can delete x2 and go for x3 and see what is it is still more. And now go for x4 and y1 and say it is negative. You see, these type of values are going to create not all times, but most of the time it is better to, there is a negative relationship. But fortunately, you see, in my data I have three constructs or factors. x1, x2, x3 represents a factor, y1, y2, y3 represents a factor, z1, z2, z3, z1, z2, z3 represents a factor. So there are three factors. So that way there is nothing wrong if we have a negative relationship between x1 and y1, and some extent it is auspicious. And now you can also choose to, since it is ordinary data, better to go for Spearman row, because Pearson is very sensitive for numerical deviations from the mean. Same negative it appears to be, and go for x2 and see whether you have more or less same. Earlier it was 0.8, and now these covariances and correlations are very much important for the structural equation modeling. Once you observe or gain understanding on nature of your data through covariances and correlations, then you can proceed ahead for structural equation modeling. Now the very first tab under structural equation modeling is EFA and SEM. In this video I'm just going to confine my demonstration to EFA and SEM. Now there is a little help text here. Entire data set is used for EFA. EFA stands for exploratory factor analysis, and I used a very noteworthy package in our community known as Psych, which is developed by Professor William Ravel, who belongs to Northwestern University. He had done really commendable work by writing a library with the name Psych, which is a sort of package in our community for psychology, psychological analysis performed in psychology, area of psychology, something like that, psychographics or psychometrics or something like that. Now the moment I open the EFA and SEM, right side there is an output. This is actually exploratory factor analysis performed for two-factor solution. This is optional. You can also perform. Actually, in my initial starting of my Just before a moment I said there are 3 factors in our data. So if that is the case, then you can come here and change 2 as 3. 2 is the default value. Now 3 is okay. Now this is the factor solution for you can choose 4. There's nothing wrong. Only thing is here you will get factor analysis for 4 factor solution, something like that. Now these are all not important for you. This is exactly the same output which we get in our studio console. Only thing is this web application just takes that output and displays the right side, which we call is the main panel in the application. Now let me seek for 3 factor solution, since I believe that there are 3 factors in my data. Now these are the factor loadings. MR1 is actually a way it is referred to, psych way of referring to factor. This is factor 1, this is factor 2, and this is factor 3. And now you just have to pick up, I think you must be knowing what is if you are watching this video, it simply means that you must be knowing at least some fundamental aspects of factor analysis, EFA, because we don't dare to read structural equation modeling without knowing exploratory factor analysis. You can find there are a few values which are positive and also strong. There are also values greater than 1, which is quietly unlikely, but sometimes it is also possible. Now this is a factor 2. There are a few of the values which are positive, which means those measured variables, measurement variables, or manifest variables gives a particular value as a matter of loading towards this factor, something like that. So we just have to pick up these positive values and explain this factor, okay? And you just read more and more about factor analysis and how it should be interpreted. There's a lot of information online, and you also have a beautiful vignette written by William Ravel, whom I mentioned a bit earlier. This vignette is called vignette is called using the psych package to generate and test structural models. There are also a couple of other things like structural equation, SEM for psych for SEM, something like that. You see here you have exploratory functions, exploratory factor analysis, and how to obtain the structure diagrams, and you also have a section for confirmatory factor analysis, and you have a detailed procedure as how to get the structure diagrams for confirmatory factor analysis. So this way you can go through this document very quickly and try to understand. It is not at all required to read, but what I'm trying to say, it's better to read this document and try to understand how the author is trying to explain performing structural equation modeling by using this package psych. But as such, this is not mandatory, and without even reading this document we can perform. I'm going to show you how to do that in web application. So if you read that document, it might be possible for you to interpret some of the statistics, estimates, or parameters described in this output. H2 is actually the communality. So you need to read what is the communality. It is just sum of the squares of the loadings done row wise, and this should be maximum. So this speaks about the belongingness of this particular variable to the factor structure, something like that. And U2 or U square, this is not U2 U square, this is H square. U square is uniqueness, and this should be the value of the uniqueness is also should be a bit reasonable. Need not be close to 1, but should be reasonable enough to distinguish. This speaks about the distinction of that particular variable from the factor solution or structure. Now this is COM, known as complexity, and that should be close to 1, which means it merely speaks about the importance of that given variable for the factor structure, something like that. So if you really know excuse me, exploratory factor analysis, you should be knowing how to interpret all these values. And this is the little more information about the factors. Sum of squares loadings and proportion variance and cumulative variance. If you observe, 72% of the variance is being addressed by this three-factor solution through the data. I mean, the 72% of the variance in the data is being explained by three-factor solution, which we performed using the psych library. Now, proportion of explained, the cumulative proportion. These are the proportions of the factors. And now there is a little more. If you observe the factor correlations, some of the relationships among the factors appears to be negative. Sometimes it is also expected, and the more distinct the factors and more lesser the correlations across the factors. This is one blind rule that we need to remember. Obviously, that makes some intuition. Now there are a couple of other measures. One of the important measures is chi-square value. Here, if you see, it is 8.19, and for 11 degrees of freedom. And there is RMSR, root mean square residuals. It should be close to 0 if the fit is, if this solution has goodness of fit. And there is Tucker-Lewis index of factor reliability. This is close to 0.6, which need to be 0.9 to have some acceptable level of structure. So this is all about the EFA. Now, how to convert this EFA into the SEM output? The simplest way is to click on the structure diagram. So you'll get a very nice diagram of factor structure. This is, don't misunderstand, this is not a structural equation modeling output. This is just a factor diagram. You see there are three factors here, MR1, MR2, MR3. That is how the factors are defined in psych package. There is also covariance between MR1 and MR3. It is minus 0.4. And these are the loadings, and all the loadings, almost all loadings are positive, and these are the manifest variables. And this is the structural model of the EFA. And in case if you don't know anything about EFA and how to perform structural equation modeling using EFA, you just have to choose this option. I don't know anything, please fit EFA, something like this. Now your output tend to be different. This is actually, this option work through a particular function called omega. Omega is one of the important statistical measure used in reliability analysis, and this function is used in order to compute the loadings for a common factor in the data. Just like as we have guessed that there are three factors, you see now the solution is a little bit distinct. x1, x2, x3 loads to f2, y1, y2, y3 loads to the output. Shows the output is rather more clear compared to EFA. And now f3, z1, z2 is as we expected. Really? Isn't it? We thought that there are three factors in the data, and the factors are three factor solution. And these loadings represents the common factor in the data. You see almost all values are positive. And in case if you would like to see the structure diagram for this, you have to press this option omega fit, and now you can go through the structure. It looks quite a bit rational. It looks to be exactly a diagram for the structural equation modeling. You'll see there are three latent variables. They're not exactly latent variables, but factors. I cannot call latent variables because we are yet to go to the CFA. This is just an EFA. There are three factors. This is actually a factor diagram, a structure diagram for the factor analysis, something like that. On the left side you have a common factor, we call it general factor, and all the variables fits to a common factor, though we have three different factors, but in fact it is possible for us to see one and only one common factor in the data, and all the except just one manifest variable, I mean the measurement variable. But that is not a problem actually. Most of the variables have positive loadings towards the common factor. So this is what is called the omega, which is a little bit close to structural equation modeling. And there's a lot of other measures here. You can see the chi-square value and with a p-value in order to take the inference from the analysis. As I told you that omega belongs to area of operations called reliability analysis. Here you can see the alpha, the other equivalent alternative measure, which is very one of the potential statistic widely used and interpreted in the reliability analysis. It is called Cronbach alpha. But William Ravel explains that omega is far better compared to alpha when it comes to reliability analysis. Now omega value is 0.92, which is exceptional, and the alpha value is 0.8, which is also not bad, and most of the values is the internal consistency is acceptable. And now this is all about the EFA, performing EFA. To perform the EFA, just have to choose this option, and then here you have to define number of factors. Since I assume that there are 3 factors, I have chosen the value 3. By default you will be having 2 here. And you want to see the structure diagram, you can press this button, and you will bottom of the, in case if you would like to use this output, you can just copy and paste in your text application. And if you want to use your structure diagram, you can again right click, open image or save image, copy image, something like that. I'm going to open my text application. I use LibreOffice Writer because I'm using Ubuntu 18.04. Now we can come here and paste. You see, you got a beautiful, and now the code always will be in Liberation Serif, and this is open source font from here. You can the above, this is the Times New Roman, above output is obtained, something like that. You can start writing, and you want to paste the diagram, you can come here and paste the diagram. You can just this is a, you can start writing or interpreting the diagram. You can also increase the size of the diagram in case if you want. So this way we can make the reports. So making the reports is not a problem with this web application. If you don't know how to fit EFA, you choose this button, and for this option the omega fit is the button which creates the visual. Okay, thanks for watching this video, and this is how we perform the structural equation modeling through EFA. If you like my video, please press like and stay tuned for the new content. Thanks.